Okay, what is this part called?
Actually, this is the housing. Okay, the complete part will look like this. Okay, we'll use some corner relief, then pins, then flanged holes. Okay, these are cutouts. So there is some.
No, okay.
Okay, this is not flanged hole. This one is circular stab.
Okay, I think I'm going to restart my system. Okay, it's not coming.
Okay. Chinna, take it.
Okay, yeah. Your screen is black.
Just a second. I think now.
Yeah.
Okay, so just draw a sketch with 50 mm length, and this is YZ plane. It's not just a second. What is the reason I'm drawing?
Why is it plain, right?
No, just a second. Yes, YZ plane.
50 mm.
Yes.
Okay.
Okay, then come back, exit sketch. Then we'll have the option extrusion. Okay, extrusion optional. Usually extrusion we'll use for some whatever profile we require. For that we'll use extrusion. I mean,
Yeah,
instead of
then for that I need to give the sheet metal parameters, right?
yes,
What are the parameters?
parameters are
2 and 4.
wait, this relief thing, I think. Yeah, 2 and 4 is thickness and bend radius. Round relief, L1 is 1 mm and L2 is 2 mm.
Okay. Yeah. Okay, now extrusion.
Extrusion profile is sketch. Limit 1 is 100 mm, limit 2 is 0. So here automatic bend is given, I mean it is checked. Okay.
Yeah.
So what is automatic bend? If there is any bend in our profile, I mean in the sketch if you have given any bend, then bend means you need not give corner. If there is a bend in the profile, then it will take automatic bend there. Okay. So you understood, right? I'll show you other example. So this is all right. So for this extrusion, if you do extrusion, if you select this, when we give automatic bend, it will create these bends.
Okay, okay.
If you don't give that, it will only create normal profile.
Okay.
If you give automatic bend only, it will create.
Automatic bend, the default bend radius, right?
Yes. So in our case, there is no bend here. So we are not bothered about that. Okay. So after that, actually here, what we are doing is we have created an extrusion, then we are using wall on edge, and again we are using one more wall on edge. Then we are giving bend here. Okay. So bend value 4 mm and it is according to the parameters only. Okay. So up to here, actually, you can do in a single extrusion itself. Okay.
Yeah, we create
See,
the
this
profile.
wall on, yeah, we can edit again. So this height is 30 mm from where? From top of the surface. Okay. So what we need to do is we can also go to extrusion, and if you draw a 30 mm lines here, then with automatic bend you will achieve up to here. Okay, but for now you continue with wall on edge and cylindrical bends you can give. Anyway, you can do, no problem. You understood my point, right?
Yeah.
You can do the same 4 steps in single extrusion, or we can create like this also.
Oh, this wall on edge, we have to select the edge as the surface profile, right?
Yes. Just simply take wall on edge, select the upper edge, and give 30 mm as the distance, height.
Yeah, okay.
While giving it, we need to select this according to our need. So this is first option. So this you do in the negative Z direction, angle 90 degrees.
30 mm. It's taking the bend directly for me.
Yeah, with bend is there. One option will be there at the bottom
Yeah,
with bend.
yes, understood.
If you uncheck that, it will come only like this. You can do like that also.
Okay. After that, cylindrical bend, right?
Yes. There won't be anything called as cylindrical bend option, just you take the bend option. It will come, the name will come as cylindrical bend only.
So support 1 and support 2.
Yes. So you have to select the bottom face and this inside face.
Yeah.
Coffee, manama.
Okay. Done.
Okay. So both sides done. Na? So flange. Okay. So flange, you have to take the flange option. Then this is also very simple. Select the top edge. Then length is 25 mm. Angle is 90 degrees. Radius, if default is 4 mm, leave it like that only. Okay, select the edge.
Okay. Next.
Flange is done, na?
Hey, again your screen went dark.
See now?
Now it's okay. Yes.
Okay. So take the M option. M option where it will be in the this one only. Extrusion. After extrusion, flange is there, right? In the flange, second option.
M.
So you give hem at this line. Okay. For this. Select that edge and well, length as 6 mm you give. Okay, radius is 0. Okay, bend radius we are giving as 0 here. Okay.
Okay. Next.
Okay. So then wall on edge again.
Now again it turned dark.
Okay, before creating this, before creating this wall on edge, we need to create some planes. So create a geometrical. Okay, create a geometrical set and create planes like this. Okay, offset from YZ plane at 12 mm. Then from 12 plus 10, 22 mm. Then 52 mm again, one more.
Actually, there is something wrong with my product.
Shall I make? I'll make you presenter just a second.
I'm on the everything is inverse. It's on the opposite side.
Opposite side means Didn't get you.
See, my origin planes are here.
Okay.
So I have to create it this side. It's okay, right?
No problem. No problem. Yeah. Nothing. There won't be any issue with that. Okay. Anyway, if you want to just change as if you want to make it look as mine, just to go to the first sketch which you have drawn. Extrusion sketch. No, edit.
And
okay, so exit now again. Okay. You have drawn this in this direction only, that is fine.
yeah, that's correct only. I don't know why suddenly again.
So mine is not like this or what? What you are saying is yeah, I think extrusion you have given in the other direction, I have given in the opposite direction. Click on extrusion. Extrusion, what I have done is I have given that in negative y direction.
Yeah, I gave it in the positive. I gave it in the negative y only, I think. No?
No. Wait, in which direction I have given? I have given in positive x.
Yeah, I gave it in negative x.
Yeah.
Yeah, it's in the negative x.
No problem. Leave it like that. If you want to change, you can change.
Okay. YZ plane. I cannot create multiple planes at one go, right?
You can give at the same distance if you want. You can give.
Okay.
Repeat object after OK is there, right?
Yeah.
That you can give. That you can click and you can give 4 instances. Then later you can change the value. Okay. Are you there?
Yeah. So 10 mm.
Yes.
After that.
Oh, wait. First one is 12 mm. Then from there 10 mm. First. From that again.
Hey. Oh, okay. Now I understood. Okay.
So that is 10 mm. Okay, right. So 52 mm from this. You can give reverse direction here. Yeah. Okay, 14 mm from that. Okay, so now come back to part body. So wall on edge you have to take. Okay, you will make me the presenter. you're able to see?
Yeah.
So you take wall on edge, select this edge, okay? Then height is 10 mm, angle is 90 degrees. So it will be created in this direction, okay? Then what you have to give is in the extremities, okay? Left limit and right limit you have to give both planes, one plane in the one left limit and right limit, okay? So then it will create only this much of this much flange, it will wall on edge it will create. Okay. So like that you have to create on the 4 sides. You can create all of them with the wall on edge with the bend. Okay. You understood my point?
Yeah, but on the other side, how are you giving it? Where there are no, okay, I got it. In the planes, you can use it, right? Okay.
Yeah, same.
Mm. Okay, done.
Okay. So you got all the 4 with bench, right? Okay. So then again one more wall on edge, that is here. This one is this one we are giving with clearance. It's no clearance. Okay. 30 mm and value is 30 mm. Height is no extremities are defined. Okay, just 30 mm wall on edge with bend. Okay, this side. So your part will cut something like this.
Yeah, I'm trying to realize why is it cutting that way.
Yeah, it will cut because of the relief, but usually it should not be like this. So for this reason, we'll be giving corner relief. Okay. So for giving corner, you are done with this bend?
Yeah.
wall on edge with bend 30 mm and 90 degrees. So once you are done with this wall on edge, make it to unfold view. Unfold this. So part will become like this. Okay. So now we have to do corner relief. So what we need to do is select the corner relief option.
Hmm.
Then I will show you like which face we have to select.
Yeah, yeah, I've already selected.
Okay. Okay, select. Okay. So yes,
Hello. Hello.
yeah, Manas.
Yeah.
Hello.
Which one should I? No, which face?
So you are in unfold view, right?
Yeah.
So you have to, yeah, you have to select this face and this face. So it will be like this. Select corner relief, select this face, and give value 6.5 mm.
Hmm. Okay. Okay.
So for giving
Hold it
corner,
back.
yeah, for giving corner relief, this is the method.
You have to unfold it.
Hmm. Okay, so you can come back to normal mode or stay in the same mode. You need to draw a sketch on this face. Okay, come to unfold your view. So actually this pocket, if you want to so any profile we can give actually. So just roughly draw some profile and we have to use pocket, that's all. Okay.
This is on the side which has the planes or which doesn't have the planes.
Which doesn't have the planes.
Okay.
No, it is on the sides which we are having planes. But okay, for a moment, just leave this one. We'll go to the next step. Okay, just that is only drawing sketch. Okay, so draw this sketch on the top face. Take this one. What is this? Cylindrical.
Rectangle.
Yeah, in rectangle it will be there. Elongated hole.
Elongated, yeah.
Okay, dimensions are clear. 20 radius is 3, 17 from this edge, 29.5 from the other edge.
Radius is 2.
Radius is 2. So basically, this is these operations are similar to part design only. Okay, selecting a feature, then making a rectangular pattern, or drawing a sketch and making pocket. Okay, you'll make a pocket of this. Then take rectangular pattern and
1 second, I need the dimension.
Okay, 29.5 from. Wait, I'm going to the sketch again. Okay.
17. Okay, 29.5. Okay, done.
Okay, so make a pocket option. Take cutout. Cutout you can give up to next, or it will take defaultly 2 mm.
Okay.
Okay, so then take rectangular pattern and instances 6 and spacing is 10 mm. Instances and spacing.
Instances 6 and spacing 10. Okay.
Objective pattern is this cutout.
Reference element is the plane, I mean the surface, right?
You right click and give it.
X-axis.
Or you can select the top face also, I think.
Okay, done.
Okay, if you're selecting top face, it should be. Okay, so now circular cutout we are doing. So here you can draw a sketch. Okay, in sketch you can draw 2 points, and for those 2 points at a time you can give circular cutout. So 13 from this edge, then 18 and 12 mm, 12 mm and 18 mm, 2 points.
1 second.
So this you have to go to sketch on this face.
Yeah. It is 13 mm from the bottom edge, right?
Yes. You can give the H, I think. H, yeah. From H also you can.
Okay, done.
Okay.
So rectangular cutout, I mean circular cutout.
Yes. So take circular cutout option and select the sketch. You will get 2 these things. Circular cutout diameter is 6 mm. Okay.
Yeah.
Then we had to.
So one thing I wanted to ask. So if
Yeah.
I change the direction of the first sketch 1, 50 mm. So this entire thing will change, right?
Everything will change accordingly.
Okay, okay.
So you create a sketch, another point here in Sketcher with 12 mm from this edge and 10 mm from that edge.
Pointer?
Yeah.
And 10. Okay.
So, so sheet metal, you will be familiar now with all the options, like how to use each option. Okay. So, but after that, what you need to do is you need to study all the methods. Okay. You're saying circular stamp. You're giving it. It is what you need is you need a location, and you are giving that, and it is creating circular stamp. Okay, you are giving certain in which I am saying. Okay, so but what you need to understand is how it will be done, what are the requirements, okay, for circular stamp. Uh, what are the limitations to it. Okay, so you can see some videos of sheet metal manufacturing. Okay, how they'll do circular, whatever options are there for us in this workbench. Okay,
Yeah.
see, like circular stamp, stiffening rib. Okay, how the manufacturing will be done, you can see some videos, then you will have better understanding. Okay, so there will be, so what could be the what could be the limitations for this circular stamp?
Circular stamper.
See, you can see circular stamp means this one. They'll point a location and they will do some stamping. Stamping will be done with some hydraulic press or something like that. The sheet will deform in this shape. So here what will happen is you are not adding any material here. You are only deforming the existing metal, flat metal, you are deforming into this shape. So what will happen is here the material will expand. It will not add any new material. It will just only expand in that shape. So the available thickness will be some 2 mm or whatever the sheet thickness, that much it will be there. So this depth of this circular stamp will have some limitation. Okay. Depending on the material and the elasticity of that material.
Yeah. Or else the sheet will crack and it will tear. Yeah.
So it will depend again. It will depend on the material and the depth. Okay. So the depth will have a limitation. Okay. So like that, you have to understand the manufacturing methods. Okay. So tool wise, you will. So for you have created that point, right?
Yeah.
Yeah. Take circular stamp and the depth of this is how much? 6 mm. Okay. Radius is 1 mm, 1 mm. Diameter also is 6 mm. Angle is 80 degrees. And here you understand the angle, right? I mean it will go like a cone. That angle is 80 degrees.
So 6 mm, radius 1 na?
Hmm.
1. The angle is 80 degrees. Diameter is 6.
Yes.
Huh?
Hmm.
Okay. Yeah. But it will go 6 mm. Huh? The sheet will become very thin.
Yes. But it will be very strong. Okay. So
Okay.
in sheet metal, whenever in sheet metal, not only in sheet metal design, in any metal case, if you see, if you imagine you take some 1 feet by 2 feet sheet, okay, normal stainless steel or iron sheet, if you take, when you hold it, it will be very flexible. I mean, it will be wobbling.
Yeah. Yeah.
Okay, but if you make 2, 3 bends in that, it will become very strong. Okay, imagine now if this is a flat sheet, only the, so you can see my screen, right? So if you consider only this face is there, only this is the sheet, you make a bend here, you make another bend here, like a Z. Okay. So then what will happen is when you give the bend, its strength will increase. Okay, it will become very stiff. So in
Yeah.
sheet metal, actually, for sheet, when we add bends, it will become more stronger. Okay, that is one of the reason for giving bends also. That is the main concept of making sheet metal parts.
So this sheet metal, it is used for making the outer body of the car, right?
Yes.
Stamping.
Yes.
Mm.
That is again different. That will be done in sheet metal processes only.
Mm.
Um, they'll have that again will be having class A and class B surfaces. So class B inside in class B they'll be having all these bosses and this kind of stampings and all these things.
Okay, so where do we use this exactly? I mean, this a live example, if you can give.
Sheet metal, huh?
Hmm.
Sheet metal in all the fabrication industry will use sheet metal only.
Okay, okay.
Fabrication, wherever fabrication is done, they will do it in sheet metal only. Okay, so in normal industries means aerospace, they'll use lot of sheet metal. Or comparatively, automobile is only less sheet metal they'll use. Okay, automobile. See, this body in white is completely done in sheet metal, I think.
Okay, okay.
No. Body in white also they'll do in surface only.
Surface, yes, surface generator.
Yeah, body in white they'll use in surface. Even the bonnet and all these things, it is made of sheet, but I think they won't use sheet metal for that. All those are like mold like things, or they'll weld inside bosses will be there. For snap fitting, they'll have some fits. Okay, so all those they will have. It won't. They won't be. They won't be doing these in sheet metal. Maybe they'll use some forming techniques, hydroforming or something. They'll use and they'll get rolling. They'll do. Okay, sheet metal processes they will do definitely for getting the shapes. Okay, and sheet metal if you compare it to machine parts, they will take less loads.
Yeah, that's right.
Okay, they will take less loads compared to sheet metals. So if you consider in aerospace industry,
They take less loads or
we
more
consider
loads?
in aerospace industry less loads. So wherever
Okay.
wherever they require in aircraft means when they will use sheet metal is when they have less load requirements, and when they want to reduce the weight, they'll use sheet metal.
Hmm.
They'll be less in weight and they'll take less loads. But major advantage of sheet metal is easy to manufacture.
Yeah.
Okay.
Hmm.
So
So
this circular.
hydraulic press and then pneumatic presses and
Mm,
for bends.
that no for bench I normal for manufacturing they'll use V bends. That is press will be there. That is hydraulic press only. Pneumatic press is again pneumatic is different. I mean pneumatic systems and hydraulic systems are different. Here whatever we use, we need to have equal pressure. That's all. Okay. Mostly all bending machines will be having hydraulic presses only. Okay, but here also again bending for bending there are different types of bendings again. So this V bend is to achieve normal bends like depending on the angle we can fix the angle and we can achieve some 60, 50, 40, okay, 70 to 90 degrees bends we can get or 120 degrees bends. Okay, but apart from that there will be again rolling will be there. There will be forming methods. Okay. Forming methods will be there, bending methods will be there. Forming methods, forming means rolling. This one, what? Hydroforming will be there. Okay. Then different types of formings will be there. Then there will be chemical milling also. Milling means it will,
Yeah, I
what
know.
it,
Like
they will, yeah,
removing
they will they will remove material with the help of chemical.
chemical. Okay, okay. Chemical mill.
Okay. The chemical will eat up the the material which we don't want. So whatever material we want to retain, we will cover that with some other material. Uh, and the material which we want to remove that will be exposed to the chemical. So it will remove.
Okay,
So
okay.
there will be some time period. In this much time period, it will eat up this much like that. So
Mm-hmm.
they will leave it. They will leave it in that chemical for that much period.
Mm-hmm. Okay.
So it is actually chemical milling is banned in many of the countries,
Mm-hmm.
but in aerospace industry it is still going on.
Mm-hmm. Okay, so this stamp, what's it called? Circular stamper. Yes. I
So
have to just mirror it.
circular stamps are
Yeah, but I can't mirror it with anything.
different kind of stampings. Okay. So whatever whatever see here in our CATIA, you have like, yeah, we'll have surface stamp, bead will be there. Okay. Curve stamp will be there. Flange cutout will be there. Lower will be there. Bridge. Okay. Flange hole. Circular stamp, stiffening rim. So dowel will be there. Okay. User stamp. So all this will be different types of stamps. Mostly we'll be using circular stamp, flange hole. Okay. And okay, surface stamp also sometimes I'll use. Other things are very rare and they will be very costly processes.
Mm-hmm.
See, for example, this user flange or this what we call dowel, okay. There will be See this for user stamp, what will be? It will be just like creating a mold. Okay. So they have to create both that upper portion and bottom portion, and then they will remove that from this. Okay, those methods I don't have examples for these beads and all this. I will try to create them, and I'll show you if time in the next classes. Okay.
Okay.
In the meantime, for sheet metal, you have to observe some of the manufacturing process. You go through some videos and you understand them. Then tomorrow I will start with drawing, but parallelly, whenever I get these examples ready, I will show you the stamping other examples also. Okay. Other few of the stampings only we have left in options. All other options we have covered, I guess. Okay. And here this DXF is there. This one I already told you. We can check for overlapping. So here one overlapping is detected. It is saying that, and it is showing the overlapping is here, because here we have given 0 radius for this hem. Okay. Okay, that is that one 0 will give 0, but if they cannot maintain 0 here, but what they will do is they will simply bend it to the complete and they will press it completely like this. Okay, hem means. Okay, we can give some radius also if you want. If you give radius, gap will be there here. Actually, they will bend it such that there won't be any gap here.
Yeah.
So that's why we'll give 0 mm. So before sheet metal parts for giving manufacturing, they will check this overlapping. Okay, it should come no overlapping. And the DXF is save as DXF means it will save as a different type of file. Okay.
Okay.
So this DXF file they can directly import to the machine. Okay. They can import the DXF file into the CNC machine bending machines.
So tell me, now we are modeling in CATIA, right?
Yes.
So when it goes to the shop floor and they have to visually represent it, is there any other software which they use for visual representation?
No, mostly they'll use it in they'll use CATIA only. For other formats, if they're not using CATIA and if they're using some other software, what they will ask is they will ask us to give the step or IGS format file.
Step or IES format. Okay.
IGS.
IGS. Okay.
So then what we need to do is we have to go to file and save as. Okay. While giving save as, say from Word we'll change to PDF, something like that, right? Like that here we'll have IGS and step. Step means STF. STP. Okay, STP is step file. IGS is IGS file.
Okay. Okay.
Okay, these two files are the frequent. I mean, these two type of files are the median for other softwares. So when we save it in IGS or step file, what will happen? Say I'll save this in step file. I'm saving it in. I'll save it on desktop. Okay, I'm closing this. So the step file will be seen like this. When I open it, will convert data.
Okay, it will convert to CAT part.
No, it will convert to visualization mode, and it will be a dumb solid. See, our part body, there won't be any steps in this. It will become a dumb solid. It cannot be edited.
Mm-hmm. Okay.
Okay. It will be just a dumb solid. This is for the visual representation for others in their own softwares. They can open this in AutoCAD, any software. They can open step file and ideas files.
Okay. Okay, so this circular stamp is there, right? I want to do that rectangular pattern and on the other side.
Yes, you can use rectangular pattern. You can use mirror also.
Mirror with what will we use mirror? Which plane?
You can use a plane, but you can use a plane, or if there is no plane, you need to create plane. That's it. Yeah, here we have used a rectangular pattern only.
I'm trying to
The
use
total
that.
distance is 50 mm, right? So you can give 20 mm and instances to direction is y-axis.
Yeah, instances to
Spacing is 20 mm.
20.
Spacing is 20 mm.
Okay, got it. Yeah.
Okay, so this exercise is done. Okay, these corners we can they have given some, we have given some fillets, that's all. Okay, so go through some sheet metal manufacturing methods in YouTube or anywhere if you want. And tomorrow we'll start with drawing, and I'll cover the stamping exercises when I make them available for you. And later I'll send you a mail, a document I have created for my previous students. I'll share with you that is completely sheet metal document.
Okay.